Hello guys, let's see how we can name cycloalkenes according to IUPAC nomenclature. In the previous session, we talked about the nomenclature of alkenes. So the basic rules for naming cycloalkenes are pretty much similar as that for alkenes. But as you can see here, we have a cyclic structure which has a double bond in the ring. So the rules need to be uh, readdressed and explained here. So for naming a cycloalkene, of course, you have to add a prefix cyclo before the name of the corresponding alkene. If you have, for example, 5 carbon atoms in an alkene, it is a pentene. But if you have 5 carbon atoms in the ring along with a double bond, it becomes cyclopentene. That is one of the examples. We will discuss some more in the upcoming slides. And then, of course, you have to number the carbon atoms in the ring. So numbering will always start from the sp2 hybridized carbon in the ring, and then it will proceed towards the second sp2 carbon in the same ring and of the same double bond. So the second rule is to start the numbering from the sp2 hybridized carbon and then proceed towards the second sp2 hybridized carbon. You have to keep in mind that numbering should proceed in a direction so as to give lowest possible positions to the substituents that are present in the ring. You can have substituents attached to the different carbon atoms in the ring. So while numbering the carbon atoms in the ring, you have to keep in mind, you have to take into account the position of the substituents as well. But you have to remember that numbering will always start from an sp2 carbon and it will proceed in a direction towards the second sp2 carbon of the same double bond. If more than one double bonds are present, then numbering is done in such a way so as to give lowest position to all the double bonds. Let's see some examples here. We have a ring here and you can count the number of carbon atoms 1, 2, 3, 4, 5 and 6. We have a 6-membered ring with a double bond. So it is a cyclohexene. We add the prefix cyclo before hexene. We have a 6-carbon molecule with a double bond. It's a hexene, but because it is cyclic, we add the prefix cyclo. So it simply is a cyclohexene. You don't need to number the carbon atoms in the chain. We already know from the rules that numbering will start from one of the carbons, the sp2 carbons, and proceed towards the second sp2 carbon, or you start from this carbon and proceed towards this carbon atom. But in all cases, you will have this double bond at position 1. We don't have any substituents, so you don't need to mention the position of the double bond in this case. Here we have another example. We have 5 carbon atoms in the ring, so it's a cyclopentene, but we have 2 double bonds. So just like a pentadiene or a 5-carbon chain which has 2 double bonds, we add A to the prefix for the number of carbon atoms. So pent becomes penta, and we add a prefix di to mention the presence of 2 double bonds in an open chain. So that becomes pentadiene. Here we have 2 double bonds in a ring having 5 carbon atoms. So it becomes cyclopentadiene. And again, you don't need to mention the positions of the double bonds, because even if you change the positions of the double bonds, the relative position of both the double bonds will always be the same. If you start from here, or here, or here, or here, the numbering will always remain the same. So it's a cyclopentadiene. But now we have a 6-membered ring with 2 double bonds. And here, if you change the positions of the double bond, their relative positions will change. So you have to mention the positions of the double bonds here. And the rule says that the numbering will always start from one of the sp2 carbons and it will proceed towards the second sp2 carbon of the same double bond. So we have four different options to start numbering with. So we can start from here and proceed clockwise in this direction towards the second sp2 carbon. Or you can start from here and proceed towards the second sp2 carbon in an anti-clockwise direction. You can start from here and proceed anti-clockwise towards the second sp2 carbon, or you can start from here and proceed clockwise towards the second sp2 carbon. So we have four different options, and you have to start numbering from a carbon and proceed in a way so as to give lowest possible positions to all the double bonds. So if you start from here and proceed in this direction, the double bonds fall at position 1 and 3. If you start from here, this end, and you have to proceed in this direction, the double bonds fall at 1 and 3. But if you start from here, you have to proceed in this direction, so the double bonds fall at 1 and 5. 1, 2, 3, 4, 5. So first double bond is at 1, the other is at 5. Or you start from here and obviously you have to proceed in this direction towards the second sp2 carbon. So the double bonds fall at 1 and 5 again. So if you start from these internal carbon atoms here, the double bonds fall at 1 and 5. But if you start from these two carbon atoms, the double bonds fall at 1 and 3. So now it's up to you from where you want to start the numbering. We start from here and proceed in this direction so as to give position 1 and 3 to both the double bonds. So it's a cyclic structure. So you add the prefix cyclo. It's a 6 carbon ring, the prefix hex, and because we have two double bonds, so the prefix hex becomes hexa, and we add di for the two double bonds, so it's a cyclohexadiene. And obviously you have to mention the positions of the double bonds as well. So it's a 1,3 cyclohexadiene, or you can write it as cyclohexa 1,3-diene. Now we have again a cyclohexadiene, but now with a substituent. So we saw that in this molecule, we had two options, either to start from here and proceed clockwise, or start from here and proceed anti-clockwise. Because we did not have any substituents, it was our choice to start either from here or from here. But now we have a substituent. And here if you start from this carbon atom and proceed clockwise, the substituent falls at position 6. But if you start from here, and obviously you have to proceed in this direction towards the second double bond, so the substituent falls at 5. So you have to start numbering from a carbon atom and proceed in a direction so as to give lowest possible position to the substituent. We start from here and proceed anti-clockwise so that the methyl substituent is at 5, and that is the lowest position it can get. So it becomes 5-methyl cyclohexa 1,3-diene. Finally, we have this substituent, this molecule, and again we have 6 carbon atoms in the ring with 2 double bonds. So again it's a cyclohexadiene, and it's a 1,3 cyclohexadiene again, and we have 2 substituents now. And you can see if you start from here and proceed in this direction, the double bonds are at 1 and 3 and the substituents are at 5 and 6. If you start from here and proceed in this direction, the substituents are again at 5 and 6. So both the substituents fall at the same position when you start numbering either from here or from here. But we have two different substituents. One is an ethyl group, the other is a methyl group. Now in this case, you do not have a choice. You have to follow the alphabetical order. So in alphabetical order, ethyl comes first. So you have to start numbering from a carbon atom and proceed in a direction so as to give lowest possible position to the ethyl group. So from here, when you proceed anti-clockwise, ethyl group is at 6. If you start from here and proceed clockwise, ethyl group is at 5. So we have to start from here, proceed clockwise so that this ethyl group falls at 5 and methyl falls at 6. And when you write the names, first you have to mention ethyl group because it comes first in the alphabetical order. And so it is 5 ethyl, 6 methyl, cyclohexa, 1, 3 diene. So in this way, you can name different cycloalkenes. You can have different number of carbon atoms in the ring, and you can name them accordingly according to IUPAC nomenclature. I hope it is helpful. See you next time with another functional group, and we will discuss the nomenclature of that functional group according to IUPAC system. Thank you so much for watching.